All right, so it is question 8. It reads as follows. It's part of financial mathematics. Remember, in financial maths, you're going to be tested on annuities. You'll also be tested on simple and compound growth, as well as simple and compound decay or depreciation. So you have to be careful that whatever they're asking you, where does it exactly fall, and understand when do you use which formula, because that actually happens to be one of the leading problems that you have when it comes to financial maths. Okay, so question 8.1 says, an investor indicates that he will be able to treble the value of the investment at the end of 6 years. The interest rate is fixed and compounded monthly. Calculate the annual interest rate that the investor has to offer. Okay, all right, that the investor has to offer. Now, very important for us to keep this in mind. What you need to understand is, because of the fact that we are looking at a situation where somebody is talking about an investment, grade 12s don't know whether they should use a future value formula or a compound growth formula. It's always that question. Is it F or is it going to be A? You guys never know which one exactly to work with. Now, always remember the following. The difference between them is this. Compound growth is if there's a single amount that is invested once off, right? You may put a certain amount, you may put another amount later on, but it's not a situation where you're putting multiple amounts that are the same over the same period, because that's when an annuity will kick in now. These are two different cases. If it's once off, then it's compound. But if it's continuous, monthly, that's the weight you're looking for. Is it happening monthly? Is it happening quarterly? Is it periodic? Is it the same amount? Only then can you think of it as an annuity. Because that's the difference that you guys always struggle with, okay? Because an annuity is a sum of many payments that somebody might be making into a certain account. It has to be the same amount. It has to be over the same period of time for a certain investment period. Very important for you to keep that in mind. Now, as we're reading this, let's go back to it and see something very interesting. They didn't say this investor is going to make multiple deposits of the same amount. The question just says the value of the investment, which means it is a single investment that is being made. So these kinds of questions are not annuity questions. So 8.1 is just simply a paying question. It's what I call a paying question, right? So what I encourage you to do before you even go to the formula is just put your variables here and then populate them with the values from the story. According to the story, an investor indicates that he will be able to treble the value of the investment. We don't know how much the investment is. Because we don't know what the investment is, we're just going to put X. Because in math, if we don't know something, we call it X. But we know that later it is going to be 3 times more. It's going to treble. So it's going to be 3 times more. So the future value, in future, the amount, the accumulated value will be 3 times what we started with. All right? At the end of how many years? At the end of 6 years. All right. The interest rate is compounded monthly. Very important. Calculate the annual interest. So they want the annual interest rate that the investor has to offer. Very important. So we are interested in I. But remember, if interest is compounded monthly, we always need to remember that all our n's must be multiplied by 12, and our interest, whatever it is that we are going to substitute, needs to be divided by 12. Always remember that. Where is this coming from? From the fact that they said it's compounded monthly. Very important. Now, we are looking for I, so what I'm going to do is I'll put the compound growth formula, Y. It's not continuous repeated deposit of the same amount. It's a once-off story. So this is the formula I'm beginning with. As a mathematician, I want to make I the subject of the formula. It's up to you how you actually want to work with it, all right? So what I'm simply going to do here, I'm going to actually substitute my A as 3x. I'm going to put P as x. I've got 1 plus an unknown interest over 12, right? To the power of n. That is 6 times 12. You can put 6 times 12, or you can literally multiply 6 and 12 and get an answer of 72, which is what you might substitute here, all right? Now, if you divide both sides by x, you end up with 3 is 1 plus I over 12 to the power of 72. And then you can tell me what must go now. We can't obviously remove the 1. It's locked by the exponent. So we're going to take the root of 72 on both sides. So you take the 72 roots here. You also do the same on the left-hand side. That is going to remove root 72, or the power 72 on the right hand side, leaving you with 1 plus I over 12 is the 72nd root of 3, which is a very terrible number. Okay, after that, we're going to subtract 1. So we are looking at this. Minus 1 is I over 12. I don't like this division by 12, so I'll multiply by 12 this side and multiply all these guys by 12 on the other side. So which means the interest is going to definitely be 12 times what we are looking at there inside the brackets. So let me just put it in the right order so that you guys can see nicely. So I is going to be, let's go call our calculator and then ask it, what exactly is this going to be? So we are looking for 12 into, okay, then you go shift, you put the fraction there, not a fraction but a root, you hoist 72 in here, inside you've got a 3, okay, then you've got a minus 1 outside, you close the bracket. The final answer that I'm getting is 1845,06112. If you multiply that by 100 to convert it to a percentage, it's going to be 18.45. So this is 18.45% per annum. Very important and simple story. Moving on to the second part of this question, we're told that Samuel decides to buy a car costing 192,000. He takes out a loan for 5 years, right? At an interest rate of 12% per annum compounded monthly. Payments are made at the end of each month. Now, those words are big and very important. Payments are made at the end of each month. That tells you that when he makes payment, he's going to make continuous payments. Therefore, this implies that we are now going to start talking about an annuity at some point because it's repeated. Okay, cool. So 9.1 says calculate the monthly payments over a period of 5 years. Okay, cool. So this is pretty awesome. Let's try and figure out how our data is going to look. We're going to use the present value formula because we've got the present moment, 192,000 that somebody is being loaned. There are people who have memorized that if you are dealing with loans, it's always going to be the present value situation. Now, the advice I'll give you is when do you know that it's present value versus when is it going to be future value? It is going to be present value if you start with a lump sum of money that you must pay off until it becomes 0. That is if you start with something and then you're going to make small payments until that something has been finished to a 0. Future value annuity is basically what happens if you start with nothing. You start with nothing and then you raise wealth from nothing and then you're building wealth until you become a person who's wealthy because now in your account you have something. So this is very, very, very important for you to keep in mind. Just reading the question and try to understand, do we have a lump sum of money available now that we're trying to pay off? That is us starting with something and ending up with nothing after we've fully amortized the loan or whatever it might be. The future value is if you start with nothing, you start with 0. And then you make small payments, you're busy making small payments, you are raising wealth until you've got a lot of money. So that's the difference between knowing when to use the present value and when to use a future value annuity. In this case, this guy is borrowing 192,000. That means he is starting with something, which he needs to repay. And the question does specify, calculate the monthly repayments. So he needs to repay this over multiple payments. So that simply means to you, he's going to make multiple payments until the debt is 0. So he's trying to move this debt from 192,000 until it is nothing. Okay, so that definitely tells us we're dealing with a PV formula. So let's put on our variables for PV. We've got P here, X, I, as well as N. Let's see what we know. Well, we know that this gentleman borrowed 192,000 rands for buying this car. We also know that the interest that is being paid, that is being charged, in this case, because it's repaying, is 12% per annum. Compounded monthly means divide by 12. He's going to do this for a period of 5 years. 5 years times 12. Remember, compounded monthly, we divide I by 12 and we multiply our N by 12. Awesome stuff. You can immediately see that we don't know what X is going to be. Now, P equals X into 1 minus 1 plus I to the minus N, everything divided by I. We're looking to make X the subject of the formula. Now, here's my advice to you. To avoid overtyping, just make X the subject of the formula. How do you do that? Cross multiply the I. If you cross multiply the I, you get pi, which is something awesome. divided by, then you divide by the square bracket. So that square bracket that you see here is going to come underneath here. 1 minus 1 plus I to the power of negative n, and this is just simply equal to x. So pi over what you're looking at there is something that we can always work with. It is easy to compute because you're just going to type your calculator once and avoid over typing stuff. Okay, 192,000 divided by 1 minus 1 plus 0.12 over 12, everything to the negative 5 times. This is actually going to be negative 60. All right. Then you just go straight to your calculator and then you punch everything that you're looking at. You should definitely get an awesome answer there that tells you how much is this guy supposed to pay every month. And you can even tell if your answers are not making sense. You can't get 100,000 rands from somebody who borrowed 992,000 rands because that's a lot of money. Keep checking the answers that you have to see if they're making sense or you're making mistakes. 192,000 times I, okay, because it's pi. P times I, which is 0.12 over 12. Make sure that you don't make any mistakes. Okay, cool. So pi, it's P times I. My I is just going to be 0.12 divided by 12. I like keeping it with those over 12s because I keep looking at my answer and then it tells me that I am doing the right thing because I can see that I divided my interest with 12. If I see that, then it actually puts me at ease because I can see I'm actually doing the right things. Awesome stuff. So I've got 1 here and I have 1 plus. What's the interest? It's 0.12. Everything divided by 12, and then you go to the right, you close the bracket. Remember, for some weird reason, you guys always forget that negative sign on your exponent. So it's negative 60, and then if you press the equality sign, we're getting 4,270.93. So 4270.93 cents. It's money, so we need to round off to 2 decimal places all the time. So this is what this guy must pay on a monthly basis. Beautiful stuff. Now let's go to the next question, which is the last one of these ones. 8.2.2 says to us, after Samuel has made 45 payments, he decides to settle the balance on the loan. Calculate the lump sum that he will need to pay off the loan after he has made the 45th payment. Okay, cool. So how does that even look after he has made the 45th payment? So let's discuss the analysis of what is happening with Simon and his situation here. The original agreement is we are giving Simon an amount of 192,000. Okay, the agreement is that he's going to pay us a total of, we just got 4270. Okay, if the calculator will actually give us that, it's 4270.93. So this is the agreement. He will pay us this amount every month. And then he's going to do this for a period of how many months? Of 5 years times 12, which is going to be 60 payments in total. This is the agreement. If he does this successfully, he will fully repay us this loan. But then if you look at this, they're saying to us, instead of paying 60 times, he managed to make payments from the first time. Remember, he got a loan here. And this is something else that is also important, that the first payment is always made 1 month after the loan was granted. And then he continued again to make another payment, and then he continued again to make another payment until he made the 45th payment. He succeeded to make that payment. But then he wants to stop. So he wants to know, when I have paid 45 times, before I even get to 60 payments, how much am I owing here? What's the balance in this? What is the money owed? The outstanding balance when I'm here. After making that 45th payment, what is outstanding? Because I want to settle that debt. Now, if you want to work out the outstanding balance at a certain period of time, you are going to use 2 methods. And the one that is easier that I want you guys to use is use the present value formula, right? You're going to use the present value formula to figure out what the outstanding balance is going to be. But your n, you'll put the remaining n values that you must still repay. So what is the story now? We know what this guy is paying every month, 4,270. Okay, we know what the interest that is charged in this particular case, but we're not going to put 192 because this is old information. We've been repaying on that 192,000. So what you people will need to do in this case is just try to figure out the outstanding balance by putting the remaining months that he still had to complete the debt. So if you have 60 months to repay someone and you succeed to repay them 45 times, it means there's still 15 months that are outstanding. So the outstanding balance is worked out with the outstanding number of payments that must still be made. So we just need to work out what is OB with an end value of 15. Very simple and straight to the point. Always keep that in mind. You will never go wrong if you use that idea. Okay, so what am I saying? We are looking for the outstanding balance for somebody who is paying 427. Is it 427? What is it? Actually, I think let's go and check it quickly so that we can see what it is. It's actually 4270.93. Yes, 4270.93. 4270.93. This person is left with 15 payments. The interest charged is 12% per annum compounded monthly. Just remember, this is the outstanding payments for working out the outstanding balance, right? So normally you would say P is X into 1 minus 1 plus I to the minus N, everything divided by I. But what are we looking for? We're looking for the outstanding balance. So this changes to OB. The outstanding balance is the X value, 4270.93, okay, times 1 minus 1 plus 12% per annum compounded monthly. The remaining payments, the outstanding payments that must be made is 15. You had 60, you paid 45. So you're still left with 15 more to finish the debt. So this will simply tell you how much this guy is owing. So if he wants to settle the debt, he can come with all this money, and then we'll be very grateful if he comes with it, because it will make him a very good payer. So 4270.93. Okay, open bracket, open another bracket, no, backspace, yes. We need a 1 minus first and then a 1 plus. The interest that is being charged here is simply 0.12% compounded monthly, all right? And then you close your bracket there. You raise this to the power of something interesting. What is interesting? Well, negative 15 sounds interesting. Close the brackets, you go to the denominator, you've got 0.12, and then backspace, 0.12, and then all this has to be obviously divided by something. What is something? It has to be divided by 12 because it is compounded monthly, right? Just make sure that you're not making mistakes there. 1 minus 1 plus the interest to the power negative 15, close the brackets. If you press your calculator, they say this guy needs to come with 59,000 rands, okay? 59 to 16, so 59 to 16 point something. What is something? 59 to 16.67. Okay, cool, 0.67. If I'm rounding off my answer to 2 decimal places. So if he needs to settle the debt, this is the total amount of money that is going to need to bring in order for everything to actually be up to scratch if this guy wants to really settle all these people.